Good day everybody, welcome at our online class about heavy lift operations. The purpose of this video is in familiarization with the process only, because exact procedures and preparations can differ from vessel to vessel and they involve other aspects which we do not touch here. So first of all, what is the heavy lift? We will discuss this definition in relation to sufficiently geared tonnage. The more people from the industry you ask what they consider to be the heavy lift, the more opinions you might hear. For example, the commercial opinions such as our vessels are all equipped with the cranes of 350 metric tons lifting capacity each, so we consider the cargoes above 200 metric tons unit weight to be the heavy lifts, due to they occupy the vessel's heavy lift space within the specific modes of the crane's reach. But such definition leaves us with no understanding of the processes which take place on board of the vessel during the loading and discharge of the heavy lift, while these processes are actually contributing to its definition. Also, what can happen to be a heavy lift for one vessel might be considered as non-heavy lift for another, such as the handling of 80 metric ton unit will be more sophisticated for the vessel equipped with 2 by 50 metric ton lifting capacity cranes, where the vessel equipped with 2 by 1000 metric ton cranes can most likely load 80 metric ton unit anywhere in her cargo space and without using the counterballasting and stability improvement measures. So, the heavy lift can be defined by the following arrangements that happen on board the vessel. Arrangements during the loading and discharge by the vessel's cranes. Arrangements when the unit is stowed on board. Speaking about arrangements during the loading and discharge by vessel's cranes, our experience shows that when the vessel's own cranes are used, the heavy lift is the cargo which creates a noticeable impact on vessel's center of gravity and vessel's list by increasing them to such level during the loading and discharge that in order to compensate it, the following arrangements are required. Use of counterballasting measures, whether by moving the ballast water or by counterballasting by another vessel's cranes which is not connected to the cargo. The sequence is that once the lifting of the cargo started, the jib of the counterballasting crane goes down towards the sea, following the ballast water. When the cargo is in the air and moves into the cargo hold, then the jib of counterballasting crane turns to the left towards the shore and also follows the ballast water. And or stability pontoon installation and or relocation of the vessel's equipment, such as twin deck panels to the lower positions, and or purchase of sandbags or fixing the deadweight stowing commodity as underdeck cargo which to be loaded prior the heavy lift. So in other words, if the unit can't be loaded and discharged by the vessel crane without taking additional arrangements as described above, it is a heavy lift. Speaking about arrangements when the unit is stowed on board, the heavy lift can be identified by the summary of the following parameters. Block stowage and securing is not sufficient, because the lashing and securing method require the documented calculation for that particular unit, and the free space allowance around it to apply that lashing and securing method. And the weight of the unit makes such an impact on the surface and condition of the vessel's spot where it has to be loaded that it requires the weight spreading, which usually contains of hardwood, H-beam, steel plates, heavy lift platforms. Exact procedure might slightly differ from case to case depending on equipment the ship is fitted with, such as, for example, there are ship cranes which can be operated remotely and thus do not need use of the crane drivers, or location of the ballast panel can be in engine room instead of the bridge. However, the fundamentals remain to be similar, where it is 50 metric ton cargo to be loaded by 60 metric ton lifting capacity crane, or 1000 metric ton cargo to be loaded by 1100 metric ton lifting capacity crane. The command contains the captain, who stays on the bridge to operate the ballast panel and to command the movement of the cargo from the moment it's lifted till it's above the cargo hold close to the landing position, and the chief officer, who stays on quay to command the lifting of the cargo and then goes to the cargo hold to command its safe landing into required position. The cranes are usually operated by experienced able seamen, including bosun. Additionally, there can be the crew to hold the heavy lines to keep the cargo in required position while in the air. They are doing it from the quay and also inside the cargo hold, basically following the cargo. Communication between the captain, chief officer and the crane drivers is established via the agreed channel on portable VHF radio stations. Let's assume that today we have to load the hypothetical 800 metric tons windmill nacelle by some kind of project ship equipped with 2 heavy lift cranes having 900 metric ton safe working load each. In order to make the load process more efficient, the crane number 1 will be used for actual loading and the crane number 2 will be used for the counterballasting in addition to the use of the ballast water, because the crane jib on the heavy lift vessel is often the heavy lift as well due to its weight. So why not to take an advantage of it? Further, prior to start of the heavy lift operations, the ship might install the stability pontoon to increase her metacentric height, because when loading, the weight of the cargo, its center of gravity shifts to the top of the jib of the crane, thus raising up the center of gravity of the entire ship and bringing it closer to metacenter, further decreasing the metacentric height. Other possibilities to bring the center of gravity of the ship down is to locate the twin deck panels on the tank top of the ship, to do the lifting with the hold hatches being closed, and to open them only when the cargo is above, and to fill the ballast water bottom tanks up to full capacity. This can usually be done by filling them until the overflow is visually seen. However, for the safety reasons, the measurement with a special tank measuring appliance still to be done, because the free surface, when tank still not filled up completely, can remain. This free surface is one of the most dangerous parts, because when during the lifting the cargo is crossing the ship rails from the quay side and the ship is having almost 0 degrees least, the water can move inside that remaining free space and to cause the dynamic force that will lead to disaster. For that reason, the ship will often be kept with the least varying from not less than 0.2 up to 0.8 to 1 degree, as maximum on one of the sides, often on the side where the cargo is loaded from, in order to avoid the movement of the water caused by the presence of the free surface in the tanks. So the captain is in front of the ballast panel, chief officer is on the quay, crane drivers are in the cranes. Knowing the weight of the cargo, the chief officer asks the crane driver to lift it in steps, so to say, to transfer the weight of the cargo to the hook load. Crane number 1, 20 tons on the hook, commands the chief officer, and the crane put 20 tons of cargo on the hook. During this, the vessel will get an inclination towards the cargo, and the chief officer will ask the captain, "Captain, what is the least?" 0.2 degrees to port side, says the captain. Then chief officer will repeat the process until the least is 0.8 to 1 degrees. It means that further lifting can be done by pumping the ballast water from port side of the ship to her starboard side, the opposite of the side where the cargo is loaded from. The ballast transfer is done by the captain via ballast panel. During that process, the chief officer will be asking the crane driver about the load on the hook and the captain about the list. Once the list reaches from 0.8 to 0.2 degrees, then ballasting might be stopped to take more load on the hook by the crane and thus to bring the list up to 0.81 degrees before continuing to ballasting. Or to work with ballast and crane simultaneously, speed of ballasting is usually fixed. Thus, when the crew is experienced, then without stopping the ballasting, they can use variable speed of the crane hook to keep the list in the range 0.21 degrees on one side. This procedure with the ballasting and the crane lift repeats to bring more of the cargo weight to the crane. Once about 780 metric tons of the cargo is on the hook, the remaining amount is usually lifted by the ballast until the cargo is in the air. This is done in order to keep the crane slings as upright as possible to avoid the cargo shifts, but still to maintain the minimum 0.2 degrees of the list on one side. Once cargo is in the air and visually above the cargo hold coaming, the chief officer hands over the command to the captain, who tells the crane number 1 to turn the jeep into the cargo hold, then tells to the crane number 2 to turn his jeep to the quay side at the counterballasting measure, and then starts to pump the ballast water from starboard side to port side at the counterballasting measure as well. This process is quite slow, and usually it is limited by the speed of transfer of the ballast water from one side to another, and the speed of turning the crane at the certain load conditions. Professional crane driver will monitor the list of the vessel and will adjust the speed of turning the crane if needed. The captain is continuously monitoring the list of the vessel to ensure that it remains at 0.2081 degrees on one side. Once the cargo is above the cargo hold near the position where it has to be loaded and secured, the chief officer takes the command back, ballast operations stop, and if further counterballasting is needed, then it usually can be done by the jeep of the crane number 2. This is needed to ensure that the list is to the minimum and the cargo is touching the cargo hold with the entire footprint of the cargo unit and not just by the small part of it to avoid damages. Chief officer commands to crane number 1 to lower the hook until the cargo is in its position. Small adjustments can be done by the movement of the jeep. To avoid the confusion of the crane driver, the chief officer always gives him commands for a jeep movement such as turn jeep to your left or turn jeep to your right, one touch. The discharge process would be backwards procedure of what we have just discussed. We hope you have enjoyed this familiarization video and learned something new about heavy lift loading procedure by the ship's cranes, or watched an alternative to what you have already known or refreshed your existing knowledge. Please subscribe to our channel in order to be among the first ones to know about the next videos. Thank you for your attention and all the best.